Thank you. Thank you. Hi, welcome everyone. I'm here today to share how Thinkific is exposing a public supergraph and a little bit of my story with Thinkific and APIs. So first, what is Thinkific? Thinkific is an online platform where you can create and sell courses, build communities, and monetize memberships. Our mission is to help creators and businesses to teach what they know. And for today, my goal is to answer these two questions. How can we manage our API complexity? And how can we manage our APIs to expose more features for our creators and app developers? So let's dive into Thinkific's API journey. So looking back, before 2017, we were a monolith, a Ruby on Rails monolith, and we had the web apps, our internal apps, single-page applications, and custom integrations built by our creators to solve some specific use case using our public API. Like, for example, when they need to integrate users' data into their own CRMs. So those two things, web apps and custom integrations, would communicate through REST APIs. So we have the internal API, the internal REST API, and the public REST API. Our complexity was very low, as we were a small engineering team, mostly our R&D team, focused on features to solve our creators' problems. So before 2017, it was all REST. In 2017, I joined Thinkific. I moved from Brazil. I was working in Brazil for 3 months, and then I moved to Canada with my wife to Vancouver, Canada. And that's right about the same time where our front-end team was investigating ways to modernize our front-end applications, and they chose React. And then with React, it came the opportunity to experiment with GraphQL. So now we have a GraphQL API serving our web apps, for internal use, and then our complexity is still very low. But 2017 was also the year that we developed our first microservice, a Go microservice. Go was known to be super fast. We had some experience in the team, so why should not try that? So then we developed our first microservice in Go that was mainly to support our webhooks system. You would have a public REST API that was mainly for our custom integrations to use it for their needs. So complexity started to grow. In 2019, we decided, let's build our public API v2. And then when you look at our stack, so where should we build our API v2? Go was coming as this all-new shiny technology that we new developers want to try out, and it felt like a possible future for us at Thinkific. So let's test new things. Let's generate more experience and more expertise in Go in our team. Let's build our public API v2 in Go. But that took our complexity to the roof. API v2 was different than webhooks. API v2 had a much more connected domain with our Thinkific core domain. So in that case, we would have to share our database, which is like a very bad practice in microservice. But to be honest, it really felt like a possible future for us to go with Go and move away from Rails. But at that point, we didn't have a clear way to interact with Ruby events, the Rails background jobs, Sidekick. And we didn't invest too much time on teaching our engineers and getting them opportunity to experiment with Go. So pull requests would take longer, and also at the same time, the Rails development could not stop. So it's too early for us to try an API v2 outside the monolith, and we opt to discontinue the project. But in 2019, we also knew that we still want to someday break the monolith, or at least decouple some of the code as much as we could. So we decided to adopt a concept called modular monoliths, inspired by Shopify. And in the Rails way, that's known by the Rails engines. So Rails engines are some sort of mini Rails applications that in the future we could extract them outside the monolith, outside the main application, into their own microservices. 2019, family is also growing, so my complexity is increasing. We welcome Gabriel to our family. In 2020, we have the App Store. Thinkific released its App Store. Our goal is to allow creators to accelerate their business using apps. And we are also expanding our focus as an R&D team to not support only course creators, but also app developers. With app developers, they build third-party applications. Those third-party applications will communicate also with the public REST API. But in 2020, our team doubled. Developers with different backgrounds are coming to Thinkific. Developers with not a lot of experience in Rails coming to Thinkific. We decided that we should look at alternatives to maybe accelerate the development outside the monolith. And we decided to give another chance to microservice. So Node.js was the technology chosen for that service, but it was mainly for internal use as well. Complexity started to grow. In 2021, our API team was born. So we not only have R&D teams, feature teams, we now have non-technical teams, actually technical teams. And technical teams are supporting in different areas. In our case, we are supporting the APIs. And mostly, we are supporting the App Store and the public APIs. So some of our responsibilities include the API roadmap, what we are building, what is coming, infrastructure, what tools, systems that we can integrate into our stack to improve efficiency, security, all the other things, and best practices and guidelines on how to design APIs, secure an API, use authorization, and so on. So as part of our work as an API team was to improve our protection and control. So that's when we added to our stack the API gateway. The API gateway was a new layer that we put in front of our public APIs, and that would apply things like rate limiting, complex rate limiting, authorization using JWT, and another thing was API scoping. With API scoping, we're now able to allow developers to choose what data they need to develop the apps, and then creators to see what is being requested to have more confidence on the app that they are installing in their sites. But then we start to see a problem. R&D teams were developing new features, but those features were not going all the way to the public API. So app developers and course creators, they were not being able to leverage those APIs, leverage those features via using the public APIs. It would require more development time, more maintenance from our teams, because they were mainly building things in React and for the internal GraphQL API. So our GraphQL API was just growing bigger. And here I'm talking about more than 1,000 types on our internal GraphQL API. Which brings us to one of our questions for today. So how can we manage our APIs to expose more features for creators and app developers? Features were getting developed, but not always reaching to the public API. As a result, our public API was not expanding. It would require more time for developer, more time, more maintenance to roll out those features into the public API. So then in 2021, we decided as a company that GraphQL is our single API technology. We are not only saying now about the internal APIs, because that was already happening, we are talking about a public API, a new public GraphQL API that we're going to build. But what does that mean? Is everything GraphQL? Are we talking about a private and internal API GraphQL and a public GraphQL? But there was one more thing. Our environment became much more complex. We are now talking about more engines, more microservices. So how can we manage our API complexity? And this question is mostly summarizing all the other things that we were hearing internally with our teams. How are we going to support multiple APIs? How are we going to support multiple GraphQL APIs? Are we replicating what we have in the internal REST API with public REST API for the GraphQL? Our stack at that point is already too complex. We have the internal REST API, public REST API, internal GraphQL, and now a public GraphQL. It's a lot to manage. We need a better solution. And that's how we decided to unify our GraphQL API and build our unified graph, aka the Supergraph. But in order to implement our vision, the API team had to shift their focus to not only support the App Store, the App Platform, or public API, or public REST API. As an API team, as part of the platform, one of our objectives is to sustainably enable R&D teams to evolve our product with APIs. And how our vision translates into the architecture diagram. Now we have a centralized supergraph that communicates with subgraphs. Each service exposes their subgraph, and each team can own their own subgraph. And I say can own because we still have the monolith, and the monolith cannot be owned by only one team. But one interesting thing was coming from all of that. Our engines were now exposing subgraphs, which was also giving the teams less things to own and be able to own everything that they have inside the monolith. So we are exposing subgraphs directly from the engines. It's helping us breaking down the monolith. And this led us to a significant reduction in complexity. No, I'm kidding, it's still pretty complex. But until this point, our subgraph, our supergraph vision doesn't differentiate between internal and public APIs. So there is still one question that we want to answer. How can we manage our APIs to expose more features for creators and app developers? And our answer is through API versioning. So to recap, we have web apps, custom integrations, third-party applications, communicating with the API gateway. The API gateway accesses the supergraph. The supergraph orchestrates the requests with the subgraphs. And now we have our versions, a private version where everything that is developed at Thinkific becomes available in this private version, and teams can choose what they want to expose it publicly. It's simple for them because by default, everything is private. And then if they decide that they want to make it public, we have the beta version of our API. And with the beta version, we are giving them opportunity to share things earlier with app developers and course creators through APIs, and also the time for front-end teams and the UI to be developed as the API is ready. And that also gives confidence to our R&D teams that they can still make changes to the API as it's being released. And once they're ready, the data can be exposed in the stable version of our API. Data in the stable version requires to be deprecated and communicated in advance with our API clients to give them proper time to make changes and update the code as they need. And here's our deprecation flow. So we have mainly an easy flow if you are like just adding things to the GraphQL, but if you are removing, making changes, we need to give time for our users, for our app developers, that changes are coming. And we can verify usage through for our analytics, our metrics, on how things are going. If there are no requests for the past month, or for the past 3 months, it all depends on the complexity also of the changes. And once that's ready, communicated with all the developers, we can safely remove the fields. And all of this is possible thanks to Apollo Studio's feature, the Apollo contract. The Apollo contract allows us to seamlessly control our versions. So we have our API clients requesting the API gateway. The API gateway has basically 3 different routes. We have a private, a beta, and a stable. Those routes goes into different instances of our subgraph, our supergraph. And the supergraph is created based on the contract that it gets from Apollo Studio. And the supergraph then manages the request to the subgraphs, and subgraphs doesn't need to worry about versioning or making things publicly or not. And here, for example, we have Apollo Studio that we can go into the level of a field and type that is being used, and that gives us more confidence when we are in contact with our app developers and making those changes. From Apollo Studio, we also have the integration via Apollo Rover CLI that we can use to make integration from the CI/CD pipeline. And from CI/CD, we make a request to check if the changes that are coming to production are not going to break any of our clients. And if they are breaking, we can block, or we can allow, or we can reach out to those developers. And how do our developers control which version to use? In Node.js, we follow a schema-first development. It's pretty simple. We just add the Apollo Federation tag directive, and then in each field or type that we want to make it available in the beta or in the stable version, we tag them with the tag field. And again, if there's no tag, it's private by default. But unfortunately, we can't say the same thing about Ruby. And in Ruby, we have an approach as a code-first implementation, where it generates a lot of things for us, especially the relay connection types. And because of that, we had a lot of trouble when we were implementing Ruby, the contracts for Ruby. We got into contact with the maintainer of the gem. We did some digging into the library in order to be able to support Apollo contracts. But in the end, we were able to get to that. And this is how a Thinkific developer can choose which version they are giving to the contract. So we added this version attribute where you can select stable or beta. And then if you don't have version, that is private by default. So 2022, 2023, we conceptualized, developed, and exposed our Supergraph. Earlier this year, Thinkific released Thinkific's mobile app. And throughout the year, hundreds of branded mobile apps, all of them consuming the Supergraph. And where are we now? So recently, we released the beta version of our public Supergraph. Our beta Supergraph is available to a small set of users. We are learning along the way, and we are super excited to where this journey led us and what is about to come. As we prepare, we learn, and we get ready for our stable release. And we keep reducing our API's complexity. But there's one complexity that didn't decrease. We welcome Pietro to our family. Thank you.